Hi everybody, it's Miss Austin. I'm going to be going over your homework problems. You could either be doing these in the Desmo slides, or you could be doing them in your book, or you could print them out or ink on them on a PDF. Nevertheless, here we go. Number 1, angle B is an acute angle in a right triangle. What is a reasonable approximation for angle B if the ratio for the opposite divided by the hypotenuse is 0.67? I'm just going to sketch it so I can think about it. I don't. B is the acute angle. Okay. And it says, what is it reasonable if B is the ratio for the opposite and the hypotenuse? So I'm going to get my table. And I'm looking for 0.67 for opposite over hypotenuse. 0.67 for opposite over hypotenuse. I'm looking in this table for close to 0.67. So it looks like it's 40 is 0.64, 50 is 0.76, so it's somewhere around 40. So I'd say, I don't know, I need 42. Let's just say about 42 degrees. Estimate the values to complete the table below. So we found out today that in a right triangle, if we know that the adjacent divided by the hypotenuse is this, and the opposite divided by the hypotenuse is this, then if all we're going to do is talk about a different angle, right? If this is for angle C, and that's the adjacent over the hypotenuse, if we switch to angle A, then that side, the adjacent over the hypotenuse is going to be what this was. They're just reversed, okay? All we're doing is switching the angles. So this one right here goes here, and this ratio goes right here. Now, the opposite over the adjacent, we don't have, for angle C, the opposite over the adjacent gave me this, but I don't know what those individual values were. But I do know it's the flipped version of it. So one way to figure out what that is just take 1 and divide it by that answer. So 1 divided by 0.27. So if I had angle A and I took the opposite over the adjacent, I would get about 3.7. All right, number 3, Priya says, I know everything about a right triangle with a 30-degree angle and a hypotenuse with length of 1. Here, look. So I'm going to draw it for myself. Oh, 30, sorry. Hypotenuse is 1. It says the other angle is 60. Okay. The leg adjacent to 30 is 0.866. The leg opposite 30 is 0.5. Han asks, what would happen if a right triangle with a 30-degree angle has a hypotenuse that's 2? So it still has the 30-degree angle. Remember what we know about triangles. Angle size, they can still be similar, right? They're not going to be congruent. This is still 30, and that's still 60, but now he's saying, hey, what if that has a 2? Well, these triangles are similar, right? Angle, angle. So if that has a scale factor of 2, what would happen to both of those? Those sides would also be doubled. So that would be 1, and then what's 0.866 times 2? That'd be about 1.732. So it says help find the missing angles and lengths. So the angles would be exactly the same, okay? Because once they gave me a 30, and it's a right triangle, so now we've got the 90, that's AA, the third angle has to be 60. The missing sides, because the triangles are similar, that got blown up by 2. The other sides have to get blown up by 2, okay? Sides are doubled because triangles some more. All right, number 4. Triangle ABC is an equilateral. What is the value of x? What is the measure of angle B? All right, well, I'm going to label some more information here. This is an equilateral. If that's 8, that's 8. And they drop this down, so this is 4 and 4. Okay, so, and I see a right triangle, right? So I have one of the legs. So I have 4 squared plus I don't know squared equals my hypotenuse, 8 squared. So that's 16 plus x squared equals 64. Subtract 16 from both sides. How do we undo square? Square root. And if I use the decimal approximation, it's about 6.9. If you wanted to leave it exact as the square root of 48, you could do that either way. So x is approximately 6.9. What is the measure of angle B? Well, this word gave it all away. Equilateral triangle, what are all the angles? They have to be the same, and a triangle adds up to 180. 180 divided by 3, every angle is 60 degrees. Number 5, an equilateral triangle has a side length of 8, so it's this one right here again. Let's just use this as our picture. What is the area? How do we find the area of a triangle? It's base times height divided by 2. So I know the whole bottom here is 8 times the height. Now I notice over here they're using exact values, and that's okay. I'm going to show you how you could use your calculator to go back and forth. Now for the height, which is this guy right here, we found that to be 6.9. I'm going to show you both ways, okay? Or if you left it as the exact answer, the square root of 48, okay? So I'm actually just going to put the 6.9 in, which is what we found up here, and then divide it by 2. So I'm going to type that into my calculator. 8 times 6.9 divided by 2, we get 27.6. And then you're like, oh, shoot, these are all in radical form. That's okay. We can switch these. Look, let's just type that into our calculator. What's 16 root 3? Oh, look at that. That's probably my answer because this one was rounded. So I just switch this to decimal and I see that is it. And we could double check. I know it's not 24. 24 root 3, that's going to be bigger than, that's like 41. No, that's not it. 32, no. So there we go. Why was that when I typed it in slightly different than what I got? Because that's a rounded value. I already rounded some of those numbers off. All right, we're skipping 6. And our last problem we're doing is 7. A step has a height of 6 inches. So imagine here's a house you're trying to get into, and it's got a step, right? Right here that you have to step up to, that's 6 inches. A ramp starts 5 feet away. So here's a ramp over here. This is not drawn to scale, by the way. And do you see this triangle that's formed? Right triangle. And the angle, what can you say about the angle the ramp, the ramp starts 5 feet away from the base, making a 5.9 degree angle. So that angle right in there is 5.9 degrees. What can you say about the angle the ramp would make if the ramp started closer? So if I had to start it here, instead of 5 feet, if I had to start the ramp here versus here, maybe you can just kind of tell by my pictures. Is that angle right here compared to that 5.9? As I get closer and closer, if I had to make the ramp only that big or the ramp only that big, can you tell visually what's happening? The angle would decrease? No. Hopefully you can tell that is getting not smaller, the angle would increase. Okay? So this, because this is a shorter distance, this angle ends up being bigger. All right, and we're skipping number 8. So I hope those problems helped, and I will see you soon.